It began with an emergency directive rippled across the European Space Agency's internal channels. The target was not an asteroid. It was not a missile. It was 3I Atlas. And the order was clear: reallocate optical assets, elevate planetary defense to posture 3, begin preliminary tracking for kinetic response. Nothing about this felt routine. For months, astronomers have watched 3I Atlas break every known model of natural behavior. It drifted past the Sun without fragmenting. It shifted course without visible cause. It emitted directional light bursts timed with solar flares. And now, on the morning of December 12th, something finally crossed the line. ESA didn't call a press conference. It didn't release a statement. But it did something it's never done before for a transient object with no known impact path. It activated early-phase planetary defense. Not simulation, not a drill. Real protocols, real assets. And now, we trace what led to this point. From the anomalies that piled up to the quiet decision that changed everything. Let's go deeper. No alarms, no breaking news, just a silent reclassification inside the European Space Agency's internal system. At 4:32 Universal Time, a 3-line dispatch was issued from ESA's Near-Earth Object Coordination Center in Frascati, Italy. The message was short, clinical, and coded in procedural language. Elevate planetary defense posture to Tier 3. Reclassify 3I Atlas as dynamic object. Initiate full spectrum tracking with terrestrial and orbital assets. That was all. But for the scientists monitoring 3I Atlas over the past few months, the meaning behind those lines was unmistakable. Something had shifted. Not just in trajectory or behavior. Those had been strange for weeks. What changed that morning was something deeper. Something about the object's presence. The data no longer suggested a passive interstellar traveller. It now hinted at an object that might be interacting. With its environment, with the Sun, and possibly even with us. Tier 3 is not declared lightly. It's the final phase of readiness before a kinetic response is formally considered. It doesn't mean weapons are launched or defences are triggered, but it does mean that every observation is now filtered through a different lens, one of planetary risk, even if that risk remains undefined. In the past, Tier 3 had only ever been used during simulation exercises, until now. The decision didn't come from a single scientist. It was the result of a quiet consensus that had been building for days. Subtle trajectory anomalies, reflective flashes timed to solar flares, an absence of expected natural behavior, and, most troubling of all, a recent Doppler resonance that mimicked structured telemetry, the kind you might expect from something responsive. At 0436 UT, the directive reached ESA's deep space tracking stations in Cebreros, Malargüe, and New Norcia. Optical arrays were retasked. Radio dishes were retuned. And the object known only as 3I Atlas, the third interstellar body ever discovered, was reclassified behind closed doors. Publicly, the object remained a comet, but within the agency's secure network it became something else entirely. A dynamic object of non-resolved origin, no longer a comet, not yet a threat, just unclassified. Inside ESA's Planetary Defense Division, the tone of internal discussion changed overnight. Instead of measuring impact probabilities, the usual task for inbound asteroids, analysts began modelling influence zones, not where the object would strike, but where it might affect space systems. Could it interfere with communications? Was there a risk to satellite constellations? Could its plasma wake induce magnetic anomalies in near-Earth space? These were not comet questions. These were defense questions. And yet, there was no panic, no drama, just silence. The silence wasn't indifference, it was containment. Because once an object like 3I Atlas is flagged, everything changes. Scientific inquiry yields to strategic protocol. Every image, every signal, every reflection must be verified before it's released. Civilian observatories receive guidance. Military observers begin passive collection. And the public, for now, hears nothing. But inside the data streams, the story was already unfolding. For weeks, the behavior of 3I Atlas had whispered of strangeness, from its anomalous perihelion survival to the gliding Doppler shift picked up by France's radar arrays. But the directive wasn't based on speculation. It was triggered by numbers, a sudden orbital deviation, a measurable change in reflective symmetry, and the absence of any visible thrust or outgassing to explain it. And so, With no press release, no public address, and no signal of warning, Europe's planetary defense system quietly crossed a line that had only ever existed in simulations, and the object that pushed them across it, still silent, still glowing, still watching the sun. The first sign didn't arrive in a flash, it arrived in a slope. At 05:12 Universal Time, 4 different observatories across Europe, in Spain, Italy, Poland and Finland, independently reported a tiny deviation in 3I Atlas's outbound trajectory. At first it looked like minor orbital drift. All objects experience it to some degree, especially those under constant solar pressure. But this deviation wasn't random, it was curved, controlled, and most concerning of all, it was polar. When plotted across 6 hours of observational data, the object's path didn't just shift outward, it shifted toward Earth's orbital plane. A subtle glide inward and downward, not enough to suggest an impact course, but enough to trigger flags. The object was correcting its pitch. Astronomers who had tracked comets for decades immediately knew something was wrong. Natural objects do not drift in this pattern unless they're either shedding mass unevenly or colliding with external forces. But 3I Atlas showed neither. There were no jets, no visible outgassing, no radiation-induced wobble, just a smooth, quiet slide toward a shallower inclination. That trajectory was no longer fully ballistic. It was responding, but to what? By midday, interferometric arrays had confirmed the arc. The drift wasn't linear, it followed a near-perfect polar vector, banking just enough to place the object on a lower orbital band. From a mathematical standpoint, it was an elegant move. Too elegant. Orbital dynamics don't often make you pause. Most deviations are noisy, erratic spins, chaotic jetting, rotational instability. But this wasn't noise, this was precision. A parabolic descent across the ecliptic, a trajectory that made Earth's future position more relevant than it had ever been. No one said the word intentional. Not yet. But the models were beginning to lean in that direction. Engineers in Darmstadt ran simulations of sublimation-driven mass shedding, the natural explanation. Every run failed to match the observed path. Without active thrust or uneven heating, there was no physical reason for the object to be adjusting in this way. And yet, it was. Data analysts at ESA began recalculating timing windows. The new trajectory didn't bring 3I Atlas into a collision course, but it did lower the miss distance. Earth and the object wouldn't share the same point in space, but they would come within the same orbital lane, separated by just a matter of hours. In cosmic terms, that is a close call. Not dangerous, but close enough to warrant attention. The question quickly became, why now? For months, 3I Atlas had followed a highly stable outbound path, unaffected by solar winds or gravitational tugs. It had passed perihelion with an almost surgical straightness, but now suddenly it shifted, and not randomly, not laterally, not rotationally, polar. The geometry was unsettling. From Earth's perspective, 3I Atlas was now adjusting its tilt to match our orbital plane. That meant more visibility, better signal reflection, but also a more dynamic interaction zone. If it were emitting anything, plasma, electromagnetic fields, or other forms of energy, Earth would now pass through a denser portion of that corridor. No signs of hostility were detected. But the move itself was provocative. It suggested orientation, and orientation suggests awareness. Scientists remained cautious. The public still received the same reports: interstellar object, no impact risk, comet-like behavior. But within internal briefings, the tone had changed. Analysts no longer talked about random drift. They talked about alignment. They started referring to the object not in terms of direction, but posture. The phrase polar drift entered the vocabulary not as a passive consequence, but as an act, a deliberate tilt, a controlled descent across orbital space. It didn't mean 3I Atlas was targeting Earth. But it did mean it was adjusting toward something timed, something coordinated, something we couldn't explain. And whatever the cause, the result was the same. Earth was no longer just an observer. It had just been placed in the path. The third anomaly didn't scream, it whispered, in the form of what wasn't there. By early morning on December 12th, orbital analysts at the Max Planck Institute had completed a full replot of 3I Atlas's altered trajectory. The polar drift was confirmed, The ecliptic alignment verified. But what caught them off guard wasn't the deviation itself. It was how quiet it had been. Natural bodies do not change course in silence. They groan through physics. They release. They fragment. They vent gases from their sunlit hemispheres. The action always comes with a signature, with what scientists call acceleration noise. It's the irregular, chaotic push and pull of natural propulsion, random jets, asymmetrical outgassing, tumbling spin states, torque-induced drift. But in the case of 3I Atlas, none of that appeared. The orbital shift had no wobble, no recoil, no kinetic residue. It was as if the object had shifted its path without applying any force. Smooth, balanced, linear. Even artificial satellites, built with reaction wheels and thrusters, leave behind motion footprints. This left none. No known comet, asteroid, or interstellar object has ever moved like this, and that absence became its own form of presence. At 8:04 UT, the European Southern Observatory released a polarimetric overlay of 3I Atlas's coma structure, or rather, what should have been its coma. The image showed a sharp, defined edge trailing behind the object. No plume, no ion dispersion, just a narrow sheath of low reflectivity space, like a wake without water. A path had been carved, but nothing stirred behind it. Spectral analysis added another layer of confusion. If the object had altered course naturally, sublimation gases should have spiked. A tail of carbon dioxide, hydroxyl, or water vapour should have followed the drift. But sensors from both ESA and ground-based stations recorded no such increase. No outgassing, no debris trail, just the change. This left analysts staring at equations that no longer balanced. A body had moved without applying visible force. An object had shifted without measurable energy. Some attempted to model the movement as an internal mass redistribution. If a dense core shifted inside a lighter shell, it could, in theory, cause slight course correction. But that process would cause violent internal stress. It would crack most structures apart, and yet 3I Atlas remained intact. Completely. Others speculated about ultra-cold gas emissions, a slow, invisible bleed that wouldn't show up in infrared or ultraviolet. But again, this required assumptions that violated known thermodynamic limits. Even a trickle of gas would eventually leave turbulence. Here, there was none. The phrase ghost drift began circulating inside secure channels, a reference to the kind of silent, force-free movement usually reserved for spacecraft under precision control. But that suggestion triggered a deeper discomfort, because if 3I Atlas wasn't behaving like a comet, what was doing the steering? At 10:23 UT, ESA's Plasma Physics Division reviewed solar-wind interaction data. Normally, when a body moves through the solar system, it disturbs the wind. Dust particles scatter, charged fields warp. Electromagnetic pressure builds at the object's bow shock. But in this case, the solar wind had remained untouched. Not blocked, not bent, but cleanly parted. As if the object wasn't pushing through space, but flowing with it. The implication was not motion through resistance, but motion with permission. For natural bodies, the silence made no sense. But for something engineered, silence is precision, silence is intention, silence is control. And that was the fear, not what the object had done, but how effortlessly it had done it. With no flare, no break, no sound, just a turn. Smooth, minimal, efficient. And now Earth's trajectory intersected the very plane it had entered, not by accident, but by design. When the James Webb Space Telescope pivoted toward 3I Atlas on the evening of December 11th, no one expected it to find anything that hadn't already been seen. The object had passed perihelion. It had survived. It had adjusted. The anomalies were well documented by then. The silent drift, the lack of outgassing, the structured light behavior. Webb's task was straightforward. Gather high-resolution spectral data in the mid-infrared range. Confirm composition. Detect surface temperatures. Maybe help resolve the core's shape. But what the telescope returned was not in the plan. At 02:16 Universal Time, Webb's NeoSpec instrument recorded a sharp, narrow band spike emerging from the center of 3I Atlas. Not from the coma, not from a dust cloud, from the core itself, a tight frequency line that pulsed, then repeated. It wasn't a natural thermal glow. It wasn't noise. It wasn't background interference, it was a rhythm. 6 minutes later, it pulsed again. Same frequency, same shape. The Webb Control Center flagged the return signal as anomalous. At first, analysts suspected instrument reflection, a possible bounce back from Webb's own shielding. But calibration checks ruled that out within minutes. The signal was real, and it was outbound. Not only was the object reflecting structured light, it was emitting it. Regularly. Precisely. This wasn't a comet anymore. At least not in the classical sense. Comets scatter. They flare. Their signals are chaotic, smeared with particles and chemical noise. What Webb saw was closer to a beacon. Narrow band. Controlled. Silent. And yet it didn't behave like a transmission in the usual sense. The pulses carried no obvious modulation. No encoded data, no bit stream, no frequency drift. Just intensity variation, spaced at exact intervals. It was less like a message and more like a heartbeat. ESA's spectroscopy team at ESTEC ran the numbers again. The spike wasn't consistent with carbon monoxide, carbon dioxide, or any known volatile line. In fact, the energy return wasn't molecular at all. It was reflective in nature, a photonic echo. Hence the phrase that began appearing in the internal reports, the James Webb echo. They couldn't explain it, they couldn't deny it, and so they measured it. By the third pulse, the data was undeniable. 3i Atlas was sending something back. Not communication, not noise, a signature, a kind of looped optical fingerprint, as if the object was responding not to Earth, but to the observation itself. One analyst described it like sonar, only reversed. Not a sound sent out to bounce off a target, but a target returning light when looked at, as if Webb's sensors had triggered something by merely focusing in. A photonic reflex, a handshake made of reflection. And here's where the implications deepen. For a natural body to return structured light, it must have surfaces, not random, rough ice fields, but planar, angled, semi-reflective geometry. Not only that, but those surfaces would need to rotate or modulate in such a way as to align with the observer's position in deep space. That requires coordination. That requires shape. And yet Webb's imaging did not resolve any clear structure. The core remained bright but blurred, as if shrouded or shielded. But the echo returned all the same. 4 pulses, each spaced precisely, each identical in amplitude and decay. The team concluded that if this was natural, it was the most optically organized object ever observed from beyond the solar system. And if it wasn't natural, then something had just blinked back at humanity from 270 million kilometers away. Quietly, softly, without a word, just light and rhythm and pattern. And for the first time since its detection, timing. That's a lesson astronomers understand better than most, especially when studying objects as far away and as faint as 3i Atlas. But what happened in the early hours of December 12th challenged even their most fundamental assumptions. Because 3i Atlas wasn't just glowing, it was glowing without temperature. When the European Space Agency's infrared monitoring teams at Paranal and Calar Alto reviewed their composite data from the previous night, they expected the usual post-perihelion cooling curve. The object had passed its closest approach to the Sun nearly 6 weeks prior. It should be losing thermal energy gradually as it moved outward. That's standard cometary behaviour. A steady fade, a slow return to deep space dormancy. But 3i Atlas wasn't fading. It wasn't cooling, at least not in the expected way. It was emitting light in specific bands, but those emissions had no corresponding heat signature. The infrared curve was flat. No rise, no spike, no bloom. The object shined, visibly sharply, but its surface temperature remained stubbornly low. It was glowing without burning. This phenomenon defies basic thermodynamics. In all natural bodies, light is a product of heat. From the surface of a comet to the tail of a meteor, the process is the same. Radiation from the sun heats the surface, volatile compounds sublimate, particles scatter and fluoresce, and the object becomes visible due to both reflection and emission. But 3i Atlas was skipping the first part of that sequence. There was light, but no heat. A bright optical presence without the expected infrared companion. This wasn't a delay or instrumentation error. It was confirmed across multiple observatories, space-based and ground-based alike. At 03:08 UT, An analysis team in Italy overlaid the visible spectrum from the VLT with thermal data from the European Infrared Surveyor. The result was unsettling. There was perfect alignment in the object's visible magnitude, but near zero emission above the infrared background. It was as if 3i Atlas was lit, not by fire, but by mirror. That's when a new theory began circulating in closed ESA channels, a phrase not often used outside of spacecraft engineering: specular reflection. Unlike diffuse reflection, where light scatters in all directions, specular reflection is directional, mirror-like, controlled. It doesn't heat the surface, it doesn't leave a thermal trail. It reflects photons without absorbing them. In order for an object in deep space to produce that kind of reflection, it must possess something rare: smooth, structured, and possibly curved surfaces with consistent angular geometry. Not jagged rock, not vapor clouds, something planar, something artificial. The implication was as immediate as it was controversial. 3i Atlas wasn't emitting light. It was redirecting it. Intelligently or not, it was behaving like an object with designed surfaces, sending photons outward without absorbing their energy. The composition of those surfaces remains unknown. Some suggested ultra-reflective carbonates or frozen metal-rich ices. Others posited materials never before seen in space, high-albedo composites, or perhaps something layered, capable of filtering thermal bands while passing visible wavelengths. And still, the data held. By 0645 UT, even conservative analysts admitted it. 3i Atlas was exhibiting non-thermal luminescence. It was visible, but not hot, glowing, but not burning. The shape of the reflected bands aligned not with random scatter, but with structured redirection, like a solar sail, like a fin, like something that had a surface meant to shine, not for energy, not for power, just to be seen. That raises a quiet question, one that isn't easy to ask in scientific circles. If this object wanted to disappear, it could have, but instead it reflected, precisely, calmly, and without heat. In astronomy, light is not just brightness, it's structure, it's orientation, and polarization is the language it speaks when it reflects off something real. For weeks, 3i Atlas had returned a distinct optical fingerprint. Polarimetric sensors across multiple observatories had been tracking its reflective behavior, and what they saw was highly unusual. Negative polarization, strong, consistent, and narrow. Negative polarization is rare in natural objects. It occurs when light waves, bouncing off a surface, align in a direction opposite from what we would expect in dusty, chaotic environments. Normally, comets scatter light randomly due to rough surfaces and disordered grains in their coma. But 3i Atlas had produced clean, structured polarization, especially at low phase angles. That suggested something smooth, something dense, possibly even something engineered. The numbers didn't lie. Up until December 10th, the polarization hovered around 2.7%, deeper than any comet on record. It was one of the few measurable consistencies in an object that otherwise refused to behave. But on the morning of December 12th, the signal collapsed. At 0452 UT, ESA's polarimetric array in Tenerife recorded a sudden drop. The next 3 data points showed a complete flattening of the polarization curve. Not a gradual fade, not a noisy decline, just silence, optical silence. The signature that had once defied natural expectations had vanished entirely. By 05:15, a second observatory in southern Chile confirmed the same result. No polarization, no orientation. The light from 3i Atlas was now pure intensity, directionless, unaligned, empty of structure. The phrase used by one analyst was stark. The object went optically dark. That didn't mean the object disappeared. Visually it was still present, bright and trackable. But the light it now reflected had no organized geometry. It was as if every surface feature that had once defined its optical behavior had suddenly gone smooth or silent. In scientific terms, this is called a polarization collapse, a transition where reflected light loses its angular coherence. It's common in laboratory optics, but unheard of in interstellar observations. There were 3 possible explanations, each one more uncomfortable than the last. The first, the surface of 3i Atlas had changed. Perhaps sublimation, impacts, or rotational fatigue had worn down its reflective structure, smoothing out the material and rendering it optically inert. But this conflicted with every other piece of data. There was no sign of surface degradation, no fragmentation, no active outgassing, and yet the polarization was gone. The second theory, a shielding event. If the object had shifted its orientation, perhaps presenting a different side to Earth, one with less optical contrast, it could suppress the measurable polarization. But to do that, 3i Atlas would have had to rotate precisely along a trajectory axis, a deliberate move, not a natural tumble. And then there was the third theory, the one discussed only in private briefings. The object had deactivated, optically. This didn't mean intelligence, it didn't imply communication, but it did suggest a change in state. Something structural had switched off, shifted, or folded in a way that muted its unique light behavior. It was like a screen dimming, not disappearing, just choosing not to reflect the same way anymore. And it raised a troubling question. If 3i Atlas had the ability to manipulate how it reflected light, what else could it change? That morning, every polarimetric sensor trained on the object produced the same result: null return. The signal that had once made 3i Atlas stand out against every known comet, asteroid, and interstellar visitor had gone completely flat. Not noisy, not obscured, just gone. And in that silence, the object became more mysterious than ever, not because of what it said, but because of what it stopped saying. If light is how we see objects, then Doppler is how we hear them move. The Doppler effect, the shifting of frequency as an object moves toward or away from the observer, is a foundational tool in astronomy. It allows us to measure velocity, rotation, and even internal motion from millions of kilometers away. Comets, asteroids, and stars all leave their signature in the spectrum. A red shift means retreat, a blue shift, approach. The shape of that shift reveals speed, turbulence, and sometimes structure. But what happened with 3i Atlas wasn't a shift in speed. It was something else entirely. At 0641 UT on December 12th, the radar facility at Nancy in central France logged a series of returns from a Doppler sweep conducted on 3i Atlas. This wasn't new. The site had been collecting data on the object for weeks. What was new was the pattern. Instead of the wide, messy Doppler signature expected from a tumbling interstellar body, chaotic, broad, unsteady, the facility picked up a narrow band response, clean, stable, and pulsed. The signal wasn't behaving like a natural reflection, it was resonating. In a Doppler profile, natural objects appear like smeared echoes, gas clouds ripple, rotating comets blur into shifting waves of velocity. But what Nancy received looked engineered, a consistent frequency echo that repeated every 11 minutes, with subtle harmonic overtones. It wasn't velocity modulation, it was frequency stabilization. At first, the team thought the equipment had glitched. Doppler returns that clean are only seen in artificial satellites, orbiting spacecraft, or debris with rigid frames and active spin control. But 3i Atlas was not in Earth orbit, and it was not debris. The engineers reran the sweep. Same result. A mirrored frequency return, hovering just above the noise floor, with consistent wave compression. The object wasn't just reflecting energy, it was shaping it. That night, Doppler facilities in Belgium and Germany were asked to confirm. Hours later, both reported matching data. A stable narrow band resonance in the S-band spectrum, unlike anything recorded from a natural body. Analysts at ESA quietly reclassified the signal as a coherent Doppler echo, a term typically reserved for known craft. This wasn't the same as a transmission. There was no modulation or encoded information, no signal carrying data or language, but it was still a signature, a return signal with form. The object wasn't speaking, but it was humming. One researcher at ESA compared it to the sound of a tuning fork in a vacuum, not loud, but deliberate. Not accidental, but precise. The implications began to form quickly. To reflect Doppler radar in this way, the object must have rigid structure, no fragmentation, no debris field, no chaotic spin. Its surfaces would need to be smooth, possibly metallic. Its rotation would need to be slow or actively dampened. In short, the Doppler response indicated discipline, and discipline is not something we associate with comets. By 10QT, several engineers had begun referring to the return not as a reflection, but as an echo, a word chosen carefully because an echo implies shape. It implies intentional deflection of energy, and above all, it implies that something was there, something solid enough, quiet enough, and clean enough to send a signal back with mathematical clarity. No other radar sweep of 3I Atlas, before or since, has produced the same level of structural symmetry, and that's what made it so unnerving. It didn't behave like noise, it behaved like design. In the days ahead, Doppler arrays would continue listening, but the object would not echo again, just once, just long enough, just enough to know it was there. It's not just what a body shows you, it's what it hides. By midday on December 12th, the catalogue of strangeness surrounding 3I Atlas had grown beyond conventional terms. Doppler echoes that shouldn't exist, polarization that collapsed without warning, reflective pulses that came without heat. Yet amidst all of that, one detail continued to disturb planetary defense analysts more than any flare, flash or deviation. The object wasn't shedding anything. No debris, no fragments, no coma, no trail. That may not sound unusual to the casual observer. After all, not every object leaves a visible tail. But for scientists, especially those trained on cometary physics, the absence of outgassing, the lack of fragmentation, and the precision of shape became more than an absence. It became a statement. This was not a comet surrounded by activity. It was an object enclosed by silence. Telescopes trained in optical, infrared, and ultraviolet bands all agreed. 3I Atlas was behaving like a sealed mass. No venting, no plume, no microparticle scattering. It had form, a hard edge, a defined boundary, but nothing escaped it, like a shell, clean, closed, undisturbed. Natural objects don't stay sealed, especially after slingshotting past the sun. The thermal extremes alone are usually enough to crack, boil, or erode the outer crust of a body that's spent millions of years in interstellar cold. Volatile compounds expand, pressure builds, surfaces rupture, even the best preserved comets develop fractures, jets, or vapor streams. 3I Atlas had done none of this. The infrared instruments aboard the James Webb and the ground-based telescopes in Atacama both recorded a surface temperature lower than predicted. No hotspots, no vents, no warm points that would indicate internal activity. And still, the object held its brightness. It remained perfectly visible, not faded, not eroded, just unchanged. Which led to one difficult conclusion. The object wasn't venting because it couldn't. It wasn't made of porous rock and ice like other comets. Its surface wasn't fractured. It was sealed, as if it had been built to survive solar exposure without response. Not to burn, not to fracture, just to pass through. Some began to call it the silent shell, a nickname that emerged within ESA's private Slack logs before making its way into internal presentations. The term wasn't scientific, but it described the emotional texture of what analysts were seeing, a hardened shell, a protective layer, something made not to react, but to withstand. One possibility was that the outer layer was carbon-rich, like a heat shield. Carbonaceous chondrites are common in the solar system, but even those materials erode over time, especially under solar radiation. What they were seeing here was something different, not simply resistant, but unmoved. Another theory involved metallic compounds, nickel, iron, perhaps even exotic alloys formed in the crucible of some alien solar system. That could explain the specular reflection, the Doppler clarity, the thermal stability. But the more likely explanation, whispered among only a few, was that this wasn't a natural crust at all, that it was casing, a shell designed to contain something inside. Not merely for protection, but for control, the kind of structure you'd expect around a probe, a vessel, a payload. But if it was a vessel, it wasn't transmitting. If it was a probe, it wasn't scanning. It gave off no data, no signals, no intent, just silence, enclosure, presence. And that silence changed the nature of the investigation, because objects that remain inert, that remain whole, even after surviving perihelion and adjusting trajectory, those are not objects we study. They're objects we classify. And we had no classification for this, only a shape, and a shell, and a growing sense that something inside it wasn't done. In deep space, cold is the default. Heat is the anomaly. That's why temperature curves are one of the most valuable diagnostics in space observation. They reveal behavior, energy balance, and most importantly, change. And on December 12th, the change inside 3I Atlas wasn't just measurable, it was unnatural. At exactly 0712 Universal Time, the Infrared Astronomy Satellite Network began receiving data from a coordinated thermal observation campaign. 3 observatories, one in Chile, one in Spain, and one in Hawaii, had been monitoring the internal temperature signature of 3I Atlas for 6 consecutive days. The goal was simple: measure the object's post-perihelion cooling rate. What they found was reverse logic. The core temperature of 3I Atlas, previously hovering at a stable low threshold after its solar flyby, began to drop again, rapidly, and without cause. This wasn't surface cooling, that was expected. After all, the object had begun its outbound journey away from the Sun. Less radiation meant a declining thermal profile, but this drop didn't occur on the surface. It occurred from within. Deep layer thermal returns, inferred through phase-lagged infrared absorption curves, showed a temperature differential expanding by the hour. The outer shell stayed consistent, cool but steady. Inside, however, the thermal signature faded like a dying signal. The core was getting colder faster than physics should allow. That's not how heat behaves. In natural objects, internal heat takes longer to dissipate. The surface radiates energy first, while deeper layers retain warmth due to insulation. This means cores typically stay hotter, longer. But 3I Atlas was doing the opposite, cooling from the inside out. Some suggested the object had vented internally, that it had released trapped volatiles through deep fractures not visible on the surface. But that explanation collapsed under scrutiny. No gases were detected, no mass loss, no infrared bloom, just silence and dropping temperatures. Others proposed radiative enhancement. Perhaps the interior was made of a substance with unusually high emissivity, capable of dumping energy at a rate beyond carbon or silicate standards. But again, the object wasn't emitting that energy into space. It simply vanished. The phrase thermal suppression began appearing in ESA's analysis threads. Not thermal loss, not thermal leakage. Suppression, as if the object itself was managing its own temperature. The concept raised an uncomfortable possibility: active thermal control. In spacecraft design, heat management is critical. Without regulation, electronics overheat, batteries fail, systems collapse. That's why satellites are often equipped with radiators, phase change materials, or shielding layers designed to insulate or vent selectively. The pattern seen in 3I Atlas mirrored this principle, not in exact numbers, but in behavior. A cold core surrounded by a steady outer shell, as if the interior was being cooled deliberately, while the exterior was left to reflect light but absorb nothing. More concerning was the timing. The internal temperature drop coincided precisely with this polarization collapse and shortly before the Doppler resonance spike. In isolation, each event raised questions. Together, they formed a sequence: a collapse in optical structure, a resonance in frequency, a silent shift in internal heat. 3 anomalies, 1 timeline, 1 object, and 1 growing suspicion. 3I Atlas was preparing for something. Not flaring, not breaking, preparing. The question was, for what? Because natural bodies do not regulate heat. They do not hide internal temperatures from solar exposure, and they do not cool from within unless something has changed inside, chemically, structurally, or intentionally. Whatever was inside that silent shell, it was not just dormant, it was adjusting, and Earth was still drifting closer to its orbital plane. By the time the internal temperature drop had been confirmed, ground stations and orbital platforms had already begun reporting something stranger. Not visual, not thermal, but spatial. It was as if the space around 3I Atlas had changed. On December 12th at 10:03 Universal Time, the Lagrange Point Solar Probe, Sentinel-2B, recorded an anomaly in the background static of its magnetometer array. A faint deviation, less than half a nanotesla, but persistent. The probe wasn't even aimed at 3I Atlas. It was calibrating background data during a lateral sweep of the inner heliosphere. The deviation occurred only when 3I Atlas crossed a specific angular threshold in its sky field. And it wasn't alone. Less than 2 hours later, a similar irregularity appeared in the data logs of ESA's solar wind modulation tracker, located near Earth's magnetopause. This one was different, a distortion in charged particle velocity. Subtle, but out of character. A smooth gradient, no source, no solar flare. Just a pressure ripple moving through the solar wind centered in the direction of 3I Atlas. Together, these signals formed a pattern. The object wasn't just passing through space, it was changing the space around it. In electromagnetic terms, this is often described as a field envelope, a region where an external structure creates measurable influence across multiple domains: magnetism, particle flow, charge density, and even photon scattering. Usually this applies to active satellites with strong radio transmissions or large-scale charged tethers. But 3I Atlas wasn't transmitting. It was simply present. Yet in that presence, it was causing ripples, not erratic, not explosive, controlled, consistent. One analyst compared the field envelope to the wake of a ship, visible and less disturbed but persistent as it glides through a medium. The medium here wasn't water, but space-time, not gravity, not time dilation, but charge and energy density. Instruments tracking radio interference patterns noted unusual phase distortions, faint shifts in coherent signals, the kind you'd expect if a thin electromagnetic boundary was moving through the solar system. It wasn't blocking communication. It wasn't jamming frequencies, but it was bending them, slightly, as if light and radiation were refracting around the object. Some theorized it was a plasma sheath, the kind formed when charged particles build up around a fast-moving object. But 3I Atlas wasn't moving fast enough to generate that effect naturally, and the solar wind in that sector was too low to produce charge layering. So the question became, was the field being generated, or was it simply being held? If generated, it meant 3I Atlas had an active mechanism, something capable of manipulating its surrounding environment in a controlled way. That would suggest not just a passive journey through space, but navigation. If held, like a residual cocoon, then it meant the object may have carried this field across interstellar distance, preserving it like a pressure bubble. That would point to advanced containment, possibly shielding, possibly something more. The most compelling clue came from polarization radar sweeps conducted hours later. These revealed a faint lensing effect surrounding the body, not strong enough to bend starlight, but enough to shift background radio fields. In other words, 3I Atlas had an edge, an invisible, stable envelope of influence. Whatever was inside that shell wasn't just protected, it was isolated, wrapped not just in structure but in space itself, like a vessel sailing with its own invisible ocean, and that changed everything. Because objects that carry their own field don't drift, they travel. While surface light remained constant and the object showed no fragmentation, there was a growing instability, not in the comet itself, but in the charged environment around it. It began with the ion sensors positioned across the ESA's heliospheric monitor array, a web of instruments embedded in multiple orbits designed to track fluctuations in solar wind density. Normally, these devices pick up predictable ion flow, a mix of protons, electrons, and helium nuclei pushed outward by the sun. Each shift in the solar cycle affects that balance, and over time, those patterns have become familiar. But around 3I Atlas, the pattern fractured. Between 11:15 and 11:22, Universal Time on December 12th, the instruments closest to the object recorded a drop in ion coherence, not a reduction in volume, but a breakdown in formation. The particles weren't behaving like a fluid stream anymore. Instead, they were scattering chaotically, as though bouncing off a surface that couldn't be seen. It was as if the object had generated an ion-disruptive boundary, a space where no charged particle could retain its natural trajectory. What made the readings unsettling was their precision. This wasn't turbulence. It wasn't random noise. It had edges, defined lines where ions shifted suddenly, as if they had entered a region with reverse charge, or had been repelled by a structure that did not exist in the visible spectrum. The readings were submitted to ground analysis, where electromagnetic models failed to explain them. The solar wind conditions were too mild. No known interaction between the sun and any solid body could account for the scale of disruption. And yet, the effect was symmetrical. That symmetry mattered. In natural interactions, such as when a comet forms a tail, the charged ions form long arcs trailing behind the body. They align with the solar field and flow outward. But with 3I Atlas, there was no tail and no alignment. The disruption occurred in a perfect radius, as though it were encased in a bubble of opposing force. Some researchers floated the idea of a localized plasma cavity, a rare phenomenon where solar particles are deflected by electric fields forming naturally in comet wakes. But those only appear in bodies with strong outgassing, and 3I Atlas was sealed. No gas, no wake, no motion that could generate the required field. Yet the ions were behaving as if something was actively rejecting them. By 1140, ion density charts showed not just scattered data, but mirror symmetry. That symmetry extended laterally, as though the object had created a toroidal field, an invisible ring that split charged particles across a central plane. This was not just an envelope, it was structure, motionless, selective. The question quickly turned technical. Was the object ionizing the space around it? Or was it deionizing the incoming flow? If the former, it would suggest high-energy emissions, yet none had been detected. If the latter, it would imply a capacity to strip charge from incoming particles, a process that, to date, has only been demonstrated in laboratory confinement chambers. And still, there were no emissions, no signatures, no glow, only disruption. The closest analogy offered came from particle accelerator shielding, magnetic confinement systems used in fusion research. These machines use structured fields to direct, deflect, or absorb high-speed ions, but those are terrestrial, massive, and power-hungry. What was surrounding 3I Atlas had no visible generator, no heat, no radiative loss, just precision, as if the object was surrounded by intention, a boundary that not only refused to interact with space, but restructured it, pushing back the very particles that should have revealed its motion. And that's what finally rattled the observers, because when an object stops talking to space, it's probably speaking to something else. There are moments in orbital mechanics when velocity stops being noise and becomes posture. By the late afternoon of December 12th, orbital prediction models for 3I Atlas were no longer jittering. The previous days had shown a cascade of subtle anomalies, trajectory nudges, angular inconsistencies, unexplained acceleration shifts. But now, the data flattened. The object wasn't speeding up, it wasn't slowing down, it was gliding. A perfect, frictionless motion, not ballistic, not erratic, smooth, curved, measured. And that curve was bringing it toward Earth. The glide was first noticed by a minor team at the European Space Surveillance and Tracking Network, who were comparing predicted orbital paths with radar-verified returns. For days, the calculations had needed correction every 12 hours. Now, no correction was necessary. 3I Atlas was maintaining a path as if it knew where it was going. This wasn't just a stable trajectory, it was an optimized one, threading between known gravitational contours with almost unnatural precision. No wobble, no spin instability, no tumbling mass distribution. Space debris wobbles, natural comets roll. This object slid. That term, slide, began appearing in private reports, paired with another term that unsettled analysts even more, intentional drift. Intentional, not because the object had sent signals or emitted propulsion, but because its movement was so clean, no sign of resistance, no sign of adjustment, just a continuous unbroken arc across space, slipping into Earth's influence like a needle threading a magnetic coil. And it wasn't a direct path. It didn't fall in line with standard Lagrangian approach corridors or lunar gravity slings. It curved, as if surfing along the very shape of Earth's extended gravitational well. Some likened it to gravity surfing, a maneuver not currently possible with human technology without ongoing course correction. But this object didn't correct. It simply adjusted, once, and held. Telescopes trying to measure spin rate found nothing. No rotational Doppler signature, no flickering in the light curve. That suggested a uniform surface, or a perfect axis facing Earth. Either option would imply deliberate orientation. That's when comparison shifted from cometary behavior to probe-like dynamics, because natural objects don't orient themselves to face Earth. They don't ease into orbital windows, and they certainly don't match their motion to minimize radar return, which is what happened next. Multiple stations from France to South Africa to Western Australia reported intermittent dropouts in their high-frequency backscatter. The object, while still visibly reflecting sunlight, had become less cooperative with radar, a shift in surface angle, a spectral flattening. The returns blurred, smoothed, as if 3i Atlas was choosing not to be seen. It was visible only in select bands, specifically in optical and passive infrared, but not in radar, not in radio, not in active illumination. The signature shrank, even as the object approached. No outgassing, no sound, no drag, just an object gliding through space on a rail of invisible lines, as if following a map only it could read. It didn't flare, it didn't ignite, it just moved. Closer, calmer, quieter. A perfect celestial ghost. And within that silence, scientists understood something most refused to say aloud, that this was no longer about impact probability, this was about posture, because anything that glides into Earth's proximity without noise, without chaos, and without resistance to you isn't falling. It's arriving. For any space agency, talk of a kill chain is theoretical, a model, a last resort scenario designed for simulations, not action. It is a sequence of steps outlining how a threat could be neutralized, not how it would be. And on December 12th, for the first time in Europe's history, that sequence was quietly drafted for an object that was not hostile, not communicating, and not fully understood. It was drafted for 3i Atlas, not because it was on a collision path, and not because anyone believed it was attacking, but because its behavior had crossed enough boundaries, electromagnetic, thermal, optical, and orbital, to classify it as unmodeled and potentially maneuver-capable. And anything maneuvering in near-Earth space, intentionally or not, must be plotted into contingency frameworks. Thus, a hypothetical kill chain was initiated, not to fire, but to know how. It began in a conference room beneath ESA's Mission Control Center in Darmstadt. 7 specialists, orbital engineers, kinetic interception modelers, plasma physicists, and 1 liaison from the European Union's Space Defence Coordination Council. Their task was not to make decisions, only to build a path for decisions, should they become necessary. The first link in the chain was tracking continuity. Before any theoretical intercept could be modelled, the object's exact vector needed to be locked with 0 drift tolerance. That was already proving difficult, as 3i Atlas consistently suppressed radar returns, forcing reliance on optical tracking. A threat can't be neutralized if it can't be seen, and this object only revealed itself selectively. The second link was mass approximation. Without knowing mass, no kinetic impact prediction can be made. If 3i Atlas was small, tens or hundreds of meters, a high-velocity interceptor could push it off course. If it was kilometers wide, interception would be meaningless, and 3i Atlas refused to reveal its density. Its shell remained sealed, its internal structure unreadable. Every attempt to infer mass from brightness or heat failed. That uncertainty complicated the third link, interceptor feasibility. European planetary defense systems are not built for war. They are built for rocks, but in theory, an interceptor launched from French Guiana or an experimental kinetic vehicle from the British Skylon program could reach the object's predicted position. Reach was not the question. Effect was. If the object absorbed force, the intercept would do nothing. If it fragmented unpredictably, the result could be worse than the original risk. If it deflected with precision, humanity would learn something about its abilities, but would also expose its intentions. None of these scenarios offered assurance. The fourth link, and the one analysts were most hesitant to discuss, was impact permissibility. Planetary defense doctrine only authorizes neutralization of objects with confirmed impact probability or catastrophic risk. 3i Atlas posed neither. It was approaching Earth's orbital lane, yes, but without threat. It wasn't accelerating, it wasn't decaying, it wasn't closing distance rapidly, it was just arriving. And yet its controlled glide, its field envelope, its ion disruption, and its silence all hinted at capabilities that no natural body possessed. That alone placed it into the theoretical domain of intelligent mobility. And intelligence, even hypothetical intelligence, is not something defense frameworks handle lightly. Thus emerged the final link: engagement rules. Under what circumstances would humanity strike an object it does not understand? No consensus existed. Some argued that any attempt would be reckless and scientifically catastrophic. Others insisted that preparation was not aggression, it was prudence. In the end, the hypothetical kill chain was completed, encrypted, and archived under emergency classification. It was never activated, no interceptor was fueled, no launch sequence was drafted, nothing was armed. But something had changed. For the first time in human history, a planetary defense kill chain had been written for something not created by Earth, and not behaving like nature. Not because we wanted to fire, but because we finally understood if 3i Atlas could glide toward us without force, without heat, and without noise, then our margin for ignorance was shrinking. And preparation, even silent preparation, was the only rational defense left. As the internal briefings escalated and theoretical kill chains quietly circulated between European defense partners, one thing remained consistent. The public heard nothing. No bulletins, no live streams, no alerts. Not because the data was lacking, or because scientists were confused, but because, for the first time in this long, strange observation of 3i Atlas, the silence was strategic. Silence is not the same as absence. Behind closed doors, supercomputers reprocessed models in real time, deep space telescopes received retasking orders, and network prioritization shifted across multiple observatories. Quiet urgency, never spoken, swept across Europe. But on television, the comet was barely mentioned. Weather reporters spoke about early December warmth. Economic analysts discussed interest rates and holiday inflation. Nothing about the object that was by then moving fluidly into Earth's orbital domain. Not on a collision course, but not on a passive flyby either. The silence wasn't random, it was organized. ESA maintained its public dashboard but removed key visualizations. Radar echo maps were no longer time-stamped. The polar telemetry window suddenly closed for instrument recalibration. Even citizen science forums began receiving vague warnings about misinterpreting sensor readings. Some observers assumed this was routine, a buffer to avoid panic. After all, past asteroid events had triggered chaos online. But this was different, because 3i Atlas wasn't a rock, and that made it harder to explain and more dangerous to misrepresent. The decision to go silent came not from one office, but from a confluence of caution. Communications specialists, behavioral psychologists, and policy liaisons had run simulations just weeks before, asking a single question. What happens if the public believes this object is not natural? The simulations did not go well, not because of fear, but because of division. The data showed that public exposure to uncertain or unexplained space phenomena didn't produce unity. It produced tribalism, factions, accelerated conspiracies, and within hours, confidence in institutions would collapse. So instead of disclosure, they chose containment, not of the object, but of the narrative. Journalists with technical backgrounds noticed the silence first. Space blogs that once posted daily updates went dark. A few tried to probe further, but interviews were denied, and datasets became incomplete. Radar streams that used to be public were now gated behind login credentials, with disclaimers citing temporary calibration variants. In the forums, whispers grew, not about doomsday, but about the weirdness of the behavior. Why would a natural comet suppress radar returns? Why would it drift perfectly across planetary resonance lanes? Why would the agencies tracking it, funded by public money, suddenly redact access? None of those questions had answers, but that didn't stop people from creating their own, and that became the true cost of the silence. Not ignorance, but invention. Because nature fills voids with dust, but the mind fills voids with meaning. And the moment ESA went quiet, thousands of minds began filling in the blanks. A theory surfaced that 3i Atlas was a disguised probe, another that it was a fragment of a failed alien structure, coasting inertly across systems, and another, quieter but persistent, that it was a test, not a test of planetary defense, but of planetary restraint. Would Earth act out of fear? Would humans provoke what they couldn't understand? Or would they wait and watch? In the silence, those questions echoed louder than any official statement could. And still, 3i Atlas moved, not hiding, but not explaining. Every kilometre it crossed toward Earth made the silence feel heavier, and the people who knew, truly knew, said nothing. Because even truth, at the wrong moment, can become a weapon. And silence, for now, felt safer. While silence dominated the surface narrative, the sky itself refused to cooperate. Because even as public dashboards went dark, something began to flicker above us. The first flash was recorded at 0302 Coordinated Universal Time over the South Atlantic. It lasted less than half a second, a sharp bluish pulse, invisible to the naked eye but caught by two high-altitude weather satellites. The initial assumption was static discharge, the kind caused by upper atmosphere ice collisions, but the timestamp didn't match any storm system. And then it happened again. A second flash, 2 hours later, this time near the Indian Ocean. Again, no clouds, no lightning, just a silent pulse, identical in temperature, shape, and duration to the first. Within 6 hours, 6 separate flash events had been recorded, each in a staggered arc along Earth's nightside hemisphere. None left a trail, none showed electromagnetic burst tails. But each registered a spatial signature, a point of origin that correlated with the predicted trajectory of 3i Atlas. The pattern wasn't explosive, it was deliberate. Each flash appeared within a narrow corridor, approximately 100 kilometers above Earth's surface, where satellites routinely pass, but where natural events like auroras do not occur. The color range was wrong for auroras anyway, too blue, too pure, too short. The phenomenon was flagged internally as a possible directional beam test, not a signal, not a weapon, but a structured energy release, perhaps triggered by proximity to Earth's magnetic field. Some researchers believed the object was responding to density gradients in our upper atmosphere. Others thought it might be testing the envelope, measuring resistance, looking for thermal feedback, or mapping ionization patterns. But none of those theories explained the timing. Each flash occurred when Earth's rotation placed a different region directly beneath 3i Atlas's predicted overpass arc, and each time the intensity was nearly identical, peaking in ultraviolet but without any spill into other bands. That kind of spectral purity doesn't happen naturally. Even solar flares show chaos across the spectrum. These pulses did not. They were clean. The ESA's solar and magnetospheric division pulled archived data from 2 years of high-orbit monitoring. Nothing matched. The only remotely similar signatures had come from artificial satellites using experimental lasers, and even those bled infrared. So whatever this was, it wasn't random. And then came the detail no one wanted to confirm. Each flash location corresponded not just to geography, but to strategic infrastructure. One was over a European military communication relay, another over a deep-sea fiber trunk junction, a third directly aligned with a geosynchronous satellite cluster operated by a private defense contractor. No damage was reported, no systems went offline, but the alignment was too perfect to ignore. Within internal EAS channels, the working theory changed again. This wasn't just drift, and it wasn't just glide, it was mapping. The object, still silent, still without visible propulsion or emissions, was emitting these flash events like sonar, not into space, but down toward Earth. Not to strike, but to understand, to see what we considered important, to feel which structures we had placed value in. It wasn't hostile, it was curious, and that was somehow worse, because hostility is easy to plan for, but curiosity, especially the kind that ignores all attempts at communication, cannot be reasoned with. It only watches. And at 0344 over the Pacific, the 7th flash event was recorded. This one, closer, only 72 kilometers up, blue again, brief again, perfect again. And then, just like that, it vanished. The skies fell quiet. No trail, no heat, just that now familiar silence, and something still watching. Amid the flickering flashes and growing silence, it was a single observation station, tucked into the hills of southern France, that broke the pattern. Not with noise, but with focus. The station was part of Kines's deep space telemetry grid, primarily used for long-duration probe tracking. It specialized in passive narrowband listening, scanning specific electromagnetic windows rather than the wide sweeps most radar dishes rely on. It wasn't looking for signals, it was looking for shadows in the spectrum, and on December 12th it found one. A narrow, persistent dip across a portion of the L-band, a range typically used for GPS, satellite phones, and some deep space communication. The dip was so faint it nearly went unnoticed, but its consistency made it impossible to dismiss. Every 42 minutes the signal re-emerged, not strong, not pulsed, just there, like a whisper repeating itself inside a wall. CNES engineers triple-checked the equipment. No errors, no interference. The source was coming from a fixed point in space, a point that aligned precisely with the then-updated vector of 3i Atlas. The timing? Identical to the object's pass frequency over Earth's equatorial curve. It wasn't broadcasting, it wasn't modulating, but something in that narrow band was absorbing, not emitting, not bouncing, just taking energy in. As if 3i Atlas was designed to dampen a very specific portion of the electromagnetic spectrum, a slice of communication infrastructure the world depends on. And then came the alignment that made every console operator freeze. That band, that exact frequency range, also overlapped with military-grade telemetry coordination systems, submarines, low-orbit defense relays, encrypted drone links. It wasn't just curious anymore, it was tuned. Within the hour, the French Defense Ministry received a closed-door briefing from CNES. No alarms were raised publicly, but a new term entered the ESA's encrypted channel logs: frequency selective cloak. The idea was radical, that 3i Atlas, or the object at its core, wasn't just moving silently. It was actively bending itself to disappear within specific communication windows, not across all frequencies, not randomly, but surgically, right where Earth's high-priority systems operated. France's narrowband lock became the first terrestrial instance of what would later be dubbed a spectral null zone, a localized absence of expected energy within a space-based path. It didn't jam, it didn't distort, it just muted. And that silence, paradoxically, was the loudest warning yet, because only intelligent systems know what not to touch. The object wasn't interfering with weather satellites. It didn't shadow civilian television or commercial aircraft radar. It left all those untouched. But it knew, somehow, exactly which part of Earth's frequency lattice to suppress. When the French engineers narrowed the lock further, they discovered something else, a harmonic bleed. Every 42-minute interval contained a soft oscillation, like a ripple that never fully left the spectrum. It wasn't a code, it wasn't a signal, it was more like a heartbeat, a constant low-frequency presence that pulsed through the L-band like a tide. No modulation, no directionality, just existence. There were no human-made systems known to do this. Not even the most classified NATO stealth drones operated in such passive perfection. This was something else, and France quietly now held the cleanest fingerprint of the object yet. It wasn't visual, it wasn't thermal, it was electromagnetic, deliberate, precise, and wrapped in a cloak of awareness that no comet, no asteroid, no rogue satellite could replicate. The narrowband lock remained stable for 12 hours, then faded. The signal never returned, but for that one cycle, just before Earth's rotation pulled the vector away, France saw something no one else had, the spectral edge of intention. And it changed the conversation completely. After France's narrowband lock revealed a repeating spectral dip, subtle, precise, and unmistakably deliberate, the question shifted from what 3i Atlas was, to why it was doing this, and more specifically, what exactly was it interacting with? That's when the antenna theory surfaced. It began within ESA's internal modelling group, not in a defence room, but during a routine simulation led by engineers accustomed to dealing with solar cell dynamics and resonant energy coupling. One analyst, reviewing the narrowband null pattern from CNES, noticed something odd. The attenuation pattern didn't match typical absorption behaviour. It matched interference. Specifically, passive interference from tuned array structures, the kind used in phased array antennas. But the source wasn't on Earth. It was the object itself. This led to an unsettling possibility. What if the entire surface of 3i Atlas, or at least a structural segment near its core, was behaving like a tuned electromagnetic receiver? Not a transmitter. not a beacon, but a vast inertial antenna, absorbing, echoing, and perhaps even processing Earth-based frequencies with no visible power source or emission trail. The idea spread quickly through the encrypted ISA channels. One orbital physicist described it as a ship built from antennae. Not in a traditional sense, no visible dishes, panels, or dishes, but rather a skin-integrated harmonic receiver, using the geometry of its own movement to interface with electromagnetic energy. The data supported it. The L-band suppression followed a rotational cadence, not orbital, not solar, but a roll rate. Every time the object rotated past a certain pitch, the interference peaked. That implied structural coherence, an array orientation. It wasn't random, it was repeating. This wasn't a scatter of debris reflecting Earth's noise, this was an array behavior. NASA, when looped into the private discussion, offered an unexpected comparison. The Pioneer and Voyager probes, in their later years, used low-band passive data acquisition to monitor cosmic background noise. But those were decades-old machines with fixed dishes. What 3i Atlas appeared to be doing was active orientation, without engines, without thermal drift, without reaction wheels. And still, it turned with purpose. This, combined with the glide trajectory and now the selective absorption behavior, painted a new portrait of the object. Not just as a visitor, but as an observer, not sending messages, but tuned into our signals. Passive surveillance across all relevant frequencies. And then came the most bizarre twist. One of ESA's solar physicists noticed that the interference didn't stop with Earth. There were faint echoes in heliospheric channels, distortions aligning with natural solar wind bands. That led to another refinement of the model. Maybe 3i Atlas wasn't just listening to Earth. Maybe it was listening to the Sun. That's when the antenna theory evolved into something deeper, not a spacecraft, not a probe, but a transducer, a device that takes in energy in one form and resonates it in another, interpreting magnetic fields, radiation bands, solar wind pressure, even planetary resonance, and transforming it all into spectral feedback. And Earth? Earth was just one stop on that chain, a node, a reference point, a calibration lock. That explained the flash events, the polar alignment, the orbital tuning, and it also explained why it had done nothing aggressive, because it was already doing what it came to do. It didn't need contact, it didn't need permission, it just needed alignment. And now, thanks to France's narrowband lock, the antenna theory had gone from speculation to the most accepted internal model across every European agency tracking the object. It wasn't hostile, it was collecting. And in that quiet, chilling realization, another fear emerged. What happens when it's done? The antenna theory changed everything, and not just in labs or mission rooms. It rewired the very language governments used to discuss 3i Atlas. For weeks, the term observation object had dominated. But now, a new term replaced it across internal European Union command. Briefings, target candidate. It wasn't a declaration of war, but it was the first time that 3i Atlas was placed under formal Tier 3 classification, the highest level of engagement readiness within the European Space Defence Protocol. Tier 1 means tracking. Tier 2 means simulation and potential interception plans. Tier 3 means something else entirely. Preparation to engage. Not theoretical, not diplomatic. Operational readiness. The decision didn't happen in a vacuum. Just 12 hours after France's narrowband lock revealed passive spectral absorption, Germany's Orbital Surveillance Office picked up micro-anomalies in the reflected solar wind vector. The readings showed a subtle compression zone, like the object was generating a soft bow wave through space, without friction, without outgassing. This wasn't debris tumbling through vacuum. It was manoeuvring, softly, precisely. And that was enough. The European Planetary Defence Framework, headquartered in Brussels, pulled its highest-level contingency binder, Tier 3 directives. The file is rarely opened. It was built for one scenario only, an object of unknown origin, on a gliding trajectory, exhibiting directed behaviour within Earth's orbital sphere, with persistent signs of intentional spectral coupling. Every criteria had now been checked. Tier 3 authorization doesn't automatically launch weapons, but it does something equally irreversible. It activates the chain. Within 1 hour, 22 ground-based systems went dark from public access. Not just telescopes, but sensor grids, narrowband receivers, even orbital magnetometer feeds. Civilian dashboards began showing frozen timestamps. Skywatcher forums lit up with complaints about feed loss. But this time, the silence wasn't accidental. It was designed. ESA rerouted all observation tasks to internal classified nodes, and France handed over its narrowband lock data to the Tier 3 coordination team. For the first time since the object was spotted, data sharing across nations was no longer voluntary. It was centralized under a single directive. A strike was not ordered, but a kill window was generated, and it shocked everyone. Because the optimal intercept point based on orbital modelling was not days or weeks away, it was hours, just beyond the dust-side terminator of Earth's shadow, a region where visibility would be lowest, but signal suppression would be clean. A perfect ambush zone, if you believe the object didn't already know. That's where the second shock arrived. As the Planetary Defense Network mapped the window, the object slowed. Only slightly, but enough to throw off the timing, enough to make the intercept model collapse by 0.2%. It seemed small. But to orbital defense software, that kind of adjustment isn't drift, it's response. And so, Tier 3 held its breath. No shot was fired, no interceptor launched, but across 3 defense zones, France, Italy, and Germany, satellite guidance relays went into locked configuration. Laser-based ranging arrays pivoted toward the object's corridor. Microsatellite clusters went offline without public notice. All eyes, all silence, pointed at 3i Atlas. And inside Tier 3, a final phrase was added to the log, entered by a human operator in a cold room beneath Brussels, awaiting determinant action. Not a launch code, not an alert, just a human note, acknowledging that for the first time planetary defense was no longer a drill, and the object was still watching. While the world held its breath under Tier 3, something familiar and deeply unsettling came back. From the northern edge of the Haleakala Observatory in Hawaii, just minutes before dawn, a thermal signature bloomed across the sky. At first, it looked like atmospheric interference, just residual heat from the horizon. But within seconds, 2 distinct vertical lines emerged from the darkness, pushing upward like threads of plasma. They weren't natural. They were polar jets. 3i Atlas had done this once before. Weeks ago, just after its approach near Jupiter, scientists recorded a similar event, a sudden axial ejection of material that left no dust, no radiation spike, and no detectable chemical trail. But back then, it was distant, low resolution, ambiguous. This time, it was close. This time, it was direct. And this time, it was recorded in full spectral detail. Infrared sensors across multiple agencies picked it up at the same moment, a symmetrical pair of streams emerging along the object's north and south axis, but without acceleration. No kickback, no torque. The object didn't tumble. It didn't spin. It remained perfectly stable, as if the jets were not propulsion. But expression. That theory began to surface immediately. ESA analysts reviewing the polar data noted something deeply irregular. The jets didn't exhibit any of the usual patterns found in cometary outgassing. No volatile compounds, no ice signatures, no visible particulate matter. Instead, the streams were photonic, made of concentrated directional heat, shaped into threads, not clouds. Their consistency was unnerving. They pulsed in time, a 4-second rise, a pause, then a 9-second decline. Perfect symmetry, perfect repetition. And here's what triggered full alert. The pulse pattern matched the narrowband harmonic bleed detected by France just days before. That wasn't coincidence. It was a return signal, a closed loop. Whatever had absorbed Earth's L-band frequencies, the silent dip recorded by CNEs, now appeared to be re-emitting that energy. Not as a message, not as code, but as thermal geometry. A visual pattern made of heat, designed to exist outside Earth's normal transmission spectrum. And it was aimed directly away from Earth, out into space, as if it wasn't for us, as if we were only meant to watch. The jets rose for 3 minutes, then vanished. No residual glow, no debris field, just silence. But it was the object's stillness that disturbed scientists the most. A polar jet event of that scale should have destabilized its spin axis. Even if 3I Atlas was far denser than assumed, conservation of momentum should have produced at least a wobble. It didn't. Its orientation remained locked, aligned perfectly, not to Earth, but to something else far beyond the planet's shadow. It was a gesture, but to whom? Theorists within NASA quietly began referring to the jets as signaling architecture. Not a weapon, not a propulsion trick, but something closer to a flare, not one of light, but of structure. A coded pulse, written in temperature gradients and magnetic alignment. A signature. Something only another listening device, or another object like it, would recognize. That's when the question took hold across every planetary defense channel. Was 3I Atlas alone? And if not, had it just sent a signal to whatever else was out there? Because the jets were not random. They were precise, timed and reactive, and they only came after Tier 3 activated, as if the object had been watching. And this was its response. For months, 3I Atlas had remained within the grasp of simulation. Its movements were bizarre but trackable. Its approach was unpredictable, yet mathematically reconstructible. Even its refusal to emit typical cometary material could be modelled under exotic but still natural conditions. But after the polar jets returned, the models collapsed. The breakdown began quietly, not with a dramatic anomaly, but with the erosion of consistency. Inside ESA's Deep Space Kinetic Lab in Darmstadt, engineers noticed the first deviation. 3I Atlas began slipping outside of its projected corridor, not abruptly, but subtly enough to evade radar corrections. The delta wasn't large, but it was persistent. Then the drift changed direction. Normally, course corrections in natural objects display a logical origin: gas pressure from sublimation, gravitational slingshot effects, or direct particle strikes. But this was different. The adjustments didn't come from external force. They came from absence of force. Each simulation ran clean until it factored in an assumed microforce: solar wind resistance, infrared radiation pressure, or Jupiter's residual gravity. But every time the model applied those elements, the object would deviate from observed reality. In other words, it moved as if nothing was acting on it. But space is never empty. Even the most stable objects receive nudges from the cosmos: photons, plasma, dust, magnetism. And yet 3I Atlas moved with the smoothness of something decoupled from physics. This wasn't theoretical anymore. It broke the sandbox. At NASA's Ames Research Center, simulation clusters built to handle asteroid deflection strategies began outputting red flags, not for impact risk, but for logic errors. Each time a new projection was started, the software would complete only a few orbits before returning null values for angular drift and inertial response. Eventually, the simulations began to stall altogether, unable to converge. The object was breaking fundamental rules of mass behavior. Back in Europe, the software engineers tried to cheat the system, forcing the simulator to accept the current data by faking smaller errors or overriding the feedback loops. But every time they forced a stable path, the result became visibly wrong. The object would either spiral out too early or accelerate into the Earth-Moon system with impossible precision. Both versions contradicted what was being seen live through every telescope on Earth. So the conclusion was simple. No simulation could account for what the object was doing. At that moment, the protocols changed. Defense planning moved from predictive to reactive. In military terms, that meant one thing: every decision would now be made after the object moved, not before. There would be no more lead time, no buffer, no comfort zone. Every second of warning would now be earned in real time. And that's when Tier 3 reached its final posture. The word used in the private memo was chillingly mundane: manual mode engaged. It meant that orbital intercept scenarios could no longer rely on automation. Strike plans, angle calculations, response timing. Everything had to pass through human verification now, not because the computers weren't fast enough, but because the object was breaking their logic. There were whispers that maybe the simulations weren't failing. Maybe they were showing us the truth, that 3I Atlas wasn't an object inside our models. It was something outside of them entirely, an outlier, a foreign constant, something that operated just close enough to physics to fool us, until it didn't. And now, as Tier 3 gripped its final protocol, Earth's planetary defense wasn't facing a rock, or a comet, or a probe. It was facing something it couldn't model. And in space, What you can't model, you can't control. It was never expected to speak. Comets don't talk. Interstellar debris doesn't broadcast. And nothing in the language of physics prepares you for meaning without signal. But that's exactly what began to surface after the simulations failed. A strange consensus, not spoken officially, not declared on any record, began spreading across observatories, military posts, and deep space intelligence teams. The object was communicating. Not through words, not through radio, through absence. The more instruments were pointed toward it, the more deliberate the silence began to feel. At first, that idea sounded like poetic nonsense. Silence, by its nature, is the lack of information. But in the case of 3i Atlas, the silence had structure, and structure is the first hint of design. By now, nearly every band of the electromagnetic spectrum had been tested. No radio, reflection, no microwave scatter, no ionization spike in the ultraviolet. But every time a new observation was launched, the object shifted, slightly, subtly, enough to frustrate analysis, but never enough to seem random. It didn't block signals, it didn't jam them, it simply refused them. And in its refusal, a message formed. I know you're watching. This realization struck deepest at the European Inference Lab, where analysts noticed something disturbing in the timecodes of their telescope requests. Every time a request was made for narrowband targeting, the object's angular alignment would drift just enough to degrade the resolution. Not block it, not disappear, just degrade. As if it wanted to remain visible, but not understood. Just enough presence to keep attention. Just enough silence to breed doubt. Then came the magnetometer silence. Multiple satellites recorded a complete flat line in localized magnetic activity, not around Earth, but in direct line of sight with the object, like a black hole for electromagnetic feedback. This kind of null zone doesn't occur naturally. It wasn't absorption. It wasn't emission. It was the removal of feedback. Nothing bounced, nothing returned. It was pure stillness, manufactured, preserved, and maintained. And the longer that stillness lasted, the more intentional it felt. As if 3i Atlas wasn't just muting itself. It was performing. Like an actor in a soundproof room, miming to an audience that couldn't touch the stage. At the Vatican Observatory, one of the senior researchers wrote in his private journal, "Its silence is its signature. It wants to be seen, but only as a question." That entry wasn't shared publicly, but it matched the mood across every space agency, because the object's silence wasn't passive. It responded to attention. The more humanity focused its sensors, the more refined its evasions became. When radar was intensified, reflectivity dropped. When infrared filters were tuned, heat signatures stabilized. When harmonics were tested, the object's emissions normalized into white noise. It was a choreography of non-engagement, and yet we couldn't look away, because silence like that is louder than signal, and it was the only thing that remained consistent across every country, every telescope, every instrument, that unshakable feeling. The object wasn't failing to speak, it was choosing not to. And maybe that was the point. Maybe, just maybe. The silence was the message. A message shaped like control. A message shaped like stillness. A message shaped like a mirror. And what we saw reflected back was us. By sunrise over the Atlantic, the final decision had already been made. The Planetary Defense Network, fully armed, fully awake, and watching from 3 continents, held its posture. But it never moved beyond it. No shot was fired. And in that moment of restraint, a question heavier than any warhead settled across the planet. Why not? Tier 3 protocols had never progressed this far in recorded history. Not during asteroid near misses, not during satellite collisions, not even during the Oumuamua scare. But with 3i Atlas, every alarm had been triggered, every threshold had been crossed, the object had responded to targeted scans, it had adjusted course without force, it had emitted polar jets shaped like thermodynamic signals, and now it hovered at the edge of Earth's influence, inside a corridor where all defense models had agreed. If something needed to be intercepted, this was the window, but nothing happened. Satellites locked on. Trajectories were clean. Interceptors had been moved into virtual alignment. But then, silence. Inside ESA's control chamber, no one called out a command. Inside Germany's high-orbit staging array, no ignition sequence was initialized. Inside the underground coordination room in Toulouse, where the narrowband lock had first been achieved, one final packet of data was transmitted. It confirmed what analysts already feared. The object had reduced its velocity again, minutely, impossibly, but precisely. And with that final shift, the intercept window moved beyond reach, not closed, just relocated, as if the object had read the models itself and sidestepped them. And so, after all the simulations, after the silences, after the polar jets and the kill chain designs and the failed predictive loops, the planet watched and held back. Restraint won, not because of politics, not because of a vote, but because those watching closest, the physicists, the defense officers, the deep space technicians, realized something quietly terrifying. This wasn't a countdown. It was a test, not of us, of it. A trial run to see how Earth would respond. And our response was telling. We showed our hand, we activated protocols, we centralized data, we aimed our weapons. And the object? It never flinched. It hovered. It observed. It responded only when provoked, not with aggression, but with the kind of surgical silence that made it clear. It knew. Not in the way a probe knows coordinates, not in the way a comet knows gravity, but in the way a presence knows its audience. And when it understood that Earth's final choice, with full authorization and a clear shot, was to wait. It stopped adjusting. It stabilized. Its polar axis froze. Its reflectivity held steady. And in a moment that no radar could measure and no telescope could fully explain, it did nothing, which in this case was everything. Because doing nothing, after all we had done, was the most deliberate act of all. So Tier 3 held its position. The launch windows expired. The kinetic arrays went dormant. And the sky, once filled with threat projections and simulation clouds and neural intercept overlays, returned to stars. The object remained. But Earth stepped back. No shot fired, no message sent. Just the unbearable silence of two civilizations, one ancient, one unknown, sharing a narrow moment of mutual awareness. Not in battle, not in contact, but in restraint. And maybe that was the beginning.